Hi, I'm Thomas Stepan. I'm a product manager for our high-speed arbitrary waveform generators. Today I would like to show you how to use an arbitrary waveform generator in conjunction with our 33 GHz real-time scopes to generate PAM4 signals. I will be using our M8195 arbitrary waveform generator. This is a 4-channel instrument, so we can generate the PAM signal on any of those 4 channels or multiple signals together. Before I start with the PAM signal, I want to show you how to calibrate the setup for optimal frequency response. So what I'll do is I will run an in-system calibration which will determine the frequency and phase response of this setup. So in order to do this, I will use the in-system calibration, and if I hit the run button, the waveform generator will output some test signals and use those signals to calibrate the frequency and phase response of the system. This is the arbitrary waveform generator, including any cables or circuits that you might have in between. And you can see the progress going on, and on the screen you can see the magnitude response on the top, and you can see the phase response on the bottom. So once this is done, I can use this data as the data that I want to use for my measurements. And I can go back to my PAM generation, and in this panel I can set up the data rate, I can set up the type of data that I want to generate. In this case, I will be using a QPRBS13, and I will generate the clean signal to start with. So I download that signal, and over on the oscilloscope I will recall a setup to visualize it. So here's our PAM4 signal, and on purpose I'm using a slower data rate right now to show you some of the capabilities that the AWG has in terms of modifying and changing the characteristics of this PAM4 signal. So one of the things I wanted to show you, of course, is the ability of the AWG to change the rise and fall times of the signal. So if I increase this one, I make the signal, the slopes, slower. Now you can see the rise time it's gone down, and I can also do the other side and make the rise and fall time shorter. Of course, other impairments that I can add some jitter to the signal. Let's try that. And you can see with adding jitter, we're closing the eyes in the horizontal direction. Now, since all the waveforms are mathematically calculated, there's really no limit on the amount of jitter that you can add to the signal. So I can add some more jitter to it and effectively completely close the eye if I wanted to. The other thing I can do, let's remove the jitter again, is add noise to the levels. So I can close the eye in the vertical direction. Obviously the receivers are sensitive to noise, so I can test my receiver by artificially adding some noise to the signal. That's what I'm doing right now. I can add a little bit more and then close the eye in the vertical direction. As you can see, now the eyes get smaller. Go back to the nominal signal. Another important feature of the arbitrary waveform generator that I would like to show you is the ability to apply nonlinear distortions. Especially when you're driving an optical modulator, the optical modulators oftentimes have nonlinear transfer characteristics, and in order to pre-distort the signal for those optical modulators, you can use this AWG and use non-equidistant levels. As an example, I will use, let's say, 0, 0.2, 0.5, and 1 as my levels. And as you can see now, the levels are pre-distorted, so I have a non-equidistant spacing of the voltage levels. Now, of course, we're running at a lower data rate right now, so let me go to the interesting data rates that you might be using in your real application. So let's crank this up to, say, 25.78 Gbaud, which is the typical baud rate that's being used for Gig Ethernet, and take a look at that signal. Of course, The same thing is true here. Just need to adjust the scope a little bit. And you can see the signal looks very clean, a little less amplitude here. You can see that there's really nice and wide eye openings. With that, I conclude the PAM4 demo. You can find more information on our website. Thanks for watching.